So the absolute value of x, as x goes to 0, that is going to be the vertex, so that is a point of interest. So how do we deal with this with a limit, and how do we show what the limit is? Well, since the graph is changing from one side to the other, it is really a piecewise function. So first of all, we have to establish f of x as a piecewise function. Okay, and as x is greater than or equal to 0, we know that it's equal to x, and for x is less than or equal to 0, or less than, we'll just say less than 0, it's equal to the opposite, or negative x. So then once we've done that, to do the limit, we need to be able to do the left, to have the same from the left side and right side. So we'll do the limit as x goes to 0 from the positive side of f of x. Okay, so it's going to be this graph here, which is 0, and the limit as x goes to 0 from the negative side, we'll use this side of the graph, it's going to be equal to 0. Now, we don't really need to do this full analysis because we do know what the limit of that function is as it goes to 0, because we do already know what it looks like. So, but what happens when we're not quite sure? Okay, we need to apply this analysis. Now we need to, because we're not exactly sure. Many of us aren't familiar with this graph here. So it's the absolute value of x divided by x. So what's happening at 0? So we have to look at the piecewise function. What's happening to f of x when it's on one side of 0? And what's happening to f of x when it's on the other side of 0? Okay, so on this side of 0, we're going to end up with positive and positive. So we end up with it equals 1. Okay, it's just y equals 1. Okay, if x is 3, 3 divided by 3 is 1. If x is 4, 4 divided by 4 is 1. What about x is less than 0? Well, it's going to be negative x divided by x, or for example, negative 2 is going to be positive 2 divided by negative 2 is negative 1. Negative 3 becomes positive 3 divided by negative 3 is negative 1. So from the left-hand side, it's equal to 1. So when we establish the limit then, the limit as x goes to 0 from the positive side, well, we can use this part of the graph here, that the limit is equal to positive 1. When it comes from the negative side, just change that, it's going to be equal to positive 1. And when it comes from the negative side, the graph's going to be equal to negative 1. So it's going to look like this. Okay, so we should make it equal to 0 because we're dividing by 0, so there's a hole at 0. Okay, and it's going to be at negative 1. And from the other side, again, there's going to be a hole at 0 because we can't divide by 0. And it's going to be equal to positive 1. Okay, so the graph is going to look like this. And we can establish that there is no limit at x equals 0. Okay, the limit does not exist because it is discontinuous at that point. So when we have this, we have to consider the piecewise function. We also have to consider dividing by 0. So again, when I made a mistake at the beginning here is that I had it equal to 0, but it cannot be equal to 0 on that part. So is f of x a continuous function? No, it's not a continuous function. Okay, because it is discontinuous at 0.